Hello, everyone. Welcome to today's webinar. I'm Erin, the Operations Director here at Forestry, and today I am excited to have a very small role in our webinar. I'm actually just making a brief introduction to Matt, as he is going to give the entire presentation today. So first off, welcome. So today we're going to be talking about rethinking forest roads and really looking at how RoadEng and modern planning tools can help address some of the growing challenges that are facing forest road networks. Now, this is a presentation that was actually first given at the Council on Forest Engineering late last year, and we are really excited to now be presenting it to our full webinar audience. So rethinking forest roads for Forestry really has actually been sort of a precursor to a lot of the different changes you're actually going to see in our software. So rethinking the way that we look at some of the different tools and elements in the software regarding planning, regarding changes in our climate, changing in our aging infrastructure, and seeing the impact from when there isn't adequate design and planning and what that can do to our environment. So I'm going to pass it over to Matt. This is not your typical webinar. We are not going to be jumping into RoadEng and giving you a how-to tutorial on anything. This is really more sort of on the theoretical side. And I should also like to say a little bit of a disclaimer. Forestry is looking at a whole bunch of different incidents through this webinar. We're going to talk about them, but I should say we were not actively involved in the investigation of any of these incidents. We've leveraged publicly available data. So with that, Matt, are you ready?
I think so. Yeah, and
Awesome.
let's dive right into it here.
Yeah. Oh goodness, I like one job. It's housekeeping. I should tell everyone, if you're in the live webinar, you're muted, but you can ask questions at any time. We're going to tackle some at the end. If you're watching this in the future off of YouTube, hello, hit subscribe. We love subscribers, and you can ask questions in the comment section too. Okay, Matt.
Awesome.
You're up.
All right.
Good luck.
Cool. Well, I'll yeah, run through it. It's going to be more slide based than what we usually do. And yeah, of course, we'll ease into things. So for many in the audience today, who we are is not really a mystery, but for anyone new, at Forestry, well, we are an R&D focused civil engineering software company. Now that being said, we're in that world, and our focus is really on roads. And where's that forestry connection? Well, obviously, there's forest roads, and for us, that's where the company was born. So the original version of RoadEng was a spin-off of a commission job by a BC coast-based company called McMillan Bloedel. And the commission job was a product of them having a problem. And the problem was that they were planning roads, and the roads oftentimes ended up being more difficult to build, unbuildable, cost more, or had safety issues. So they wanted a software that they could design their roads and find better solutions, but they also wanted it to be fast. So it's yeah, we've got long ties to the forest industry. Now myself, again, kind of like who the company is, if you've listened to other webinars recently, there's a good chance I was speaking on it, but I'm our training manager and yeah, a resource road person, I guess. Now our title might be a little vague. So what are we actually talking about today? Well, we're going to touch on the importance of forest roads. Now, obviously, there's an importance for the industry, but there's an importance if we just consider their scale as well. So how many forest or resource roads there are globally, and then acknowledge that there's a cost with any road. And usually when we run through these webinars and presentations, a lot of the time our focus is on that monetary cost. But a big part of today is acknowledging that there's costs aside from just the dollars and cents, and they can be environmental costs and safety costs as well. Now, as we talk about challenges and costs and whatnot. We're going to expand that, kind of look at it through a little bit of a historical lens, and well, from the company's timeline. So from the late 80s till now, how have things changed for what is required of planners and what kind of motivates folks to do things better. And then, of course, we're going to touch on some technology advancements that help find better solutions and address those challenges. So I promised we'd touch on, well, the scale of things. So a lot of the times roads go, yeah, they're there, but they're not remarkable. And even if there's small issues, it's kind of, oh, it's just a small issue. But if we scale that up to think about how many resource or forest roads there are globally, it's an enormous number. So even those small issues can have a significant impact. But then, of course, if we look at these kind of high profile issues and when major failures occur, well, then the impact of our roads is kind of top of mind. Now, roads, alluded to it, there's a cost rather than just the monetary costs, and roads are oftentimes associated with contributing to erosion, so erosion and sediment delivery. They also can contribute to slope failures and slides. Both of those impact water pollution and stream characteristics. Roads themselves can impact streams in other ways too. And then all of that can contribute to habitat loss, but just the road itself well, takes up space. So there's habitat loss there, and then there's habitat fragmentation. So yeah, every road has some level of impact. Now again, it's kind of, well, for many of you in the audience, it's stuff that you're already aware, but not everyone thinks of road design in the same way. So if you're coming from a background that maybe you're not familiar with the design process, design can be a bit of a dirty word where it conjures up thoughts of people overcomplicating problems and dragging something out from a planning sense more than you're going to see the benefits. So that, as for us, that's not what we do. We've got to kind of, with that same lens of the commission job of make it easy to use. Well, we want to create a tool that's fast, easy to use. So you don't have to be trained in the software for years to become proficient or anything like that. But then we also want people to be able to see the information that they need to see very quickly so they can make more informed decisions. Now, another kind of common source of confusion, particularly folks that don't have that design background, is, well, they'll compare a design road to maybe a road that's a line on the map. So a planned road is a line on the map. There's lots of overlap between the mapping or GIS space and the design space, but there are some pretty distinct differences. So if you're considering a road in a GIS environment, you're probably considering it as a line on the map. Now that line could be a 3D line, and the map could include a 3D surface. But if we take it out of that lens and we look at it through a design lens, we still have the alignment, so the center line. We still have a surface, so the topo surface. But that alignment also has proper curves and tangents assigned to it, so we know we can drive safely at the design speed that we like and model it properly. But then the big thing is we've got cross-section geometry attached to the center line. And with that cross-section geometry, we can extend it out, see how we're interacting with the surrounding terrain, and the road itself becomes a surface or a series of surfaces as it interacts with the topo surface or a series of, well, surfaces representing subsurface layers too. And actually, before I get there, so we get a much better picture of what's going on. And if we compare these two images side by side, they're actually of the same project. Doesn't look too bad on the left, and it looks super gnarly on the right. So this was a client's project. It didn't get built, but the use of the design software here was a contractor wanted to plan to build a road to access a portion of their block, and the licensee or landowner came back and said, I don't think we should do that. And they threw it in the software and very clearly articulated why it was a bad idea. One, it would be cost prohibitive if you could build it, and then two, there'd be all sorts of stability issues that you'd have to navigate to build that too. Now, it doesn't have to be this big dramatic difference to have value. And if we look at this much subtler example, both alignments, horizontal alignments, are the same here from the left or the right. And at a glance, it's not necessarily clear what one's better. But when we're modeling surfaces for our roads, we can incorporate other tools to make a more informed decision. So we could just say, well, which one of these requires less dirt to move? And that's going to be useful. But then we can incorporate stuff like our hydrology tools in it. And we can see, okay, one of these actually has a problem. So we've got a case where if we built it as shown on the left, well, we'd be creating issues where we've got ponding water in our ditches, and we'd have to do something to mitigate that, or we're going to be stuck with a roadside hazard, and that roadside hazard could also soften our subgrade and cause maintenance issues. So using that design functionality to make more informed decisions and know what we're up against and come up with a better plan for implementation. So I kind of touched on the benefits of design, that kind of whole concept of making more informed decisions. Well, what happens if we get it wrong? So poorly designed roads, or what happens if we just cut corners in construction? Kind of what's at stake? Increased cost is a big one. So from a construction standpoint, a pretty obvious one, and we talk about it lots, is well, choosing the road location to minimize earthworks is a big opportunity for reducing costs. If you put the road in a silly spot, it's going to cost more to build. From a maintenance standpoint, though, it could be something more subtle. And it could be, well, we decided to cheat and steepen up our cut slope. Could be in the design or construction side. And that cut slope ravels, it fills in your ditch. Suddenly your water that's supposed to be in the ditch is not in the ditch anymore. If it rains, if you deal with it proactively and clear that ditch while you're doing maintenance, and that costs money. If you don't clear it, it's probably going to wash out your road. And then you're dealing with repairs, which also cost money and usually happen at the most inopportune time. Yeah, so construction, maintenance, repair costs are very real. There's the disruption to operational efficiency. Do I want to go from point A to point B and I've got a super arduous route to get there? Well, it would be better if I could drive on a straighter road, faster, more direct, reduce my haul costs. And then these costs, these monetary costs, feed into the environmental impacts. So all those costs have an environmental hit associated with them. If material's washing away from a road, it usually ends up in a creek. Construction requires burning diesel, contributing to CO2 and other greenhouse gases. And then these also contribute to safety issues. If your road's washed out on a blind corner and driver comes over, doesn't see it, hits the washout, ends up in the ditch, well, that's not good either. So I could certainly talk about this stuff at length using hypotheticals. But I think the whole message we're kind of looking to articulate here is better served if we focus on a few high-profile examples. So and as Aaron introduced here too, I will just emphasize I'm just pulling in publicly available information from a few high-profile events, not intimately familiar with the actual nitty-gritty details on some of this stuff. So first, we're going to talk about the 2021 atmospheric river that hammered BC. So this news story is obviously pretty real for a lot of our folks in the audience, and would have experienced this being a local event. But even if you're from elsewhere, this was in international news cycles for several days. So this storm brought landslides, flooding, lots of road washouts due to lateral movement, etc. And the reason this was in the news cycles for several days was this storm severed access between BC's lower mainland and the rest of mainland Canada. So basically all major highways, rail were disrupted due to washouts, slides, etc. And then for the lens that we're looking at this, given the Forest Road connection, any skeptics in the audience may think, well, that's a public infrastructure problem. That's the civil engineer's problem, not the industry's problem. And we aren't that lucky. So this does have connections to the forest industry. So after that big event that was in the news cycles for quite some time, Hancock put together a study, and they found that it was almost half of the slides that occurred were associated with disturbance, and 15% of the total were attributed to logging and 14% to resource roads. So there is a connection. And then, well, another argument a skeptic may have is, well, that storm was an exceptional storm, and perhaps it was well beyond what's reasonable to design for, and with that, perhaps it's well beyond what's reasonable to expect our wind infrastructure to withstand. And that argument has holes in it too. So this map, the dots are weather station locations. And there's a few spots where that storm exceeded a 1 in 100 year event. So the dark blue, almost purple, exceeds a 1 in 100 year event. The rest is all less than that. The green is less than a 50-year event, and the lighter green is even less than a 1 in 25-year event in terms of storm intensity. So we typically plan our infrastructure around longer return periods than that. And then if we really want to drive this home and look at one particular incident from this storm event that had many incidences, we can look towards Lillooet here, which was surrounded by less than a 1 in 25 year gauge readings. So this event is the Duffy Lake slide, and it is a very high profile event in the sense that it claimed 5 lives. And there's, again, that Forest Road connection. So here, individuals were in their vehicle on the highway, so Highway 99. The slide that hit them was initiated upslope, and it's associated with a forest road. So it does matter. And then to kind of keep driving the home, this stuff does matter. It's not a one-off event. So kind of just went from recent memory and looked up a few instances that I could think of. And well, 2015 log truck driver was swept off road. He was leaving his block near Hope. And again, a slide that was initiated upslope came down, hit his truck, washed him off the road, and another fatality. Not every incident is going to be something as dramatic as a landslide. And in 2017, we've got an incident to speak to that. So Valley Bottom Road. Another fatality, log truck driver, shoulder gave way. He ended up submerged in the ditch with an overturned vehicle. And these events, kind of intentionally focusing on high profile events with high cost in terms of human life and safety. But these events all have an environmental cost associated with them too. So slides, we've got the disturbance area, we've got sediment delivery. The shoulder failing, well, it's sediment delivery as well. In this case, the first responders noted in the news article that there was a diesel spill on site too. So yeah, there's an environmental cost for all of this as well. And then I think it goes without saying that there's a financial cost. Obviously, the cost of life outweighs everything else, but all of these incidents have some element of cost associated with them. And here, I believe this is BC Forest Safety Council, an example they used, but an example where the operator was a construction-initiated landslide. The operator was physically unscathed, luckily, so he took a ride down the hill. But even though he wasn't hurt, there's obviously a large environmental impact here. So disturbance area, sediment delivery, loss of inventory as we get into the trees that would have been removed from the site. And then there's a bunch of other costs associated with it. So the cost to repair the excavator, loss costs from the harvest opportunity from not being able to access the block, et cetera, et cetera. So it ends up being a fairly significant number, especially if we consider that those aren't today's values. I think it's a 2014 values that we have here for dollars and cents. So hopefully doing a reasonable job of emphasizing that this does matter. And I think the next thing to talk about is, well, what's actually influencing the outcome of this? And really, from a road standpoint, water, gravity, and geology, topography are really going to be your driving factors to consider performance. And must acknowledge that every road has some level of impact. We want to understand the impact that we expect to have beforehand and minimize it. So where does water come in? Well, water is going to be a key factor in erosion, sediment delivery, debris flows, landslides, disturbance area. And again, doesn't have to be something as dramatic as a landslide. It could just be something unspectacular, like a culvert inlet being plugged by a beaver. All of these things contribute to altering stream characteristics and water flow. And then maybe less intuitive, but weakened road prisms can have a water influence in that. So if we have standing water next to a road, it's going to soften subgrade material if it's fine grade material. So what happens if we build a road on a hillside? Well, without the road there, we've got our surface flow that travels along the surface fairly quickly. Some of that goes into the ground, and then we have our subsurface flow. Whoops, I'll go back here just. So that subsurface flow is typically moving quite a bit slower. But what happens when we cut a road into the bank? A few things. So when we're going to redirect water. So that's surface flow, all of the flow. It comes down. Typically, we have a ditch on a road. Ditch intercepts that flow. If we do things well, we have a cross drain to convey water across the road at a preferred location. If we don't, or the water can't get to the desired location, well, maybe we have spots where water travels a little ways down the road and then ponds and overtops the road. So pond at a low point and go where we may not have intended it. Aside from just that, well, intercepting and redirecting flow, that subsurface water that's percolating through the slope or through the soil, well, when it hits that cut slope, we daylight it. It's no longer subsurface flow. It ends up in the ditch, it ends up channelized, and it ends up moving a lot quicker than it otherwise would. So we're, again, contributing to concentrating water somewhere. So we do want to understand where that water's going as we plan our drainage and road geometry in general. So these mechanisms, they're old as time, I guess. It's water goes downhill. It's nothing new. And in terms of, well, that interaction with forest roads, again, nothing new. So on the left, we have a little bit of a caption from a 2008 report. I like the wording they have here. So it's citing events that happened in the 60s and 70s, but basically when started logging in steeper terrain on the BC coast. I like their wording. So the results were devastating. So many landslides initiated and cut blocks from roads during West Coast rainstorms. And then they go on to say that these landslides had a considerable cost with loss of life, degradation of fish habitat and forest land, loss of investment in forest roads, loss of silviculture investments. So yeah, these things that we're talking about are really nothing new. And then the article on the right is it's not limited to just BC either. So this headline, it's from an OSU study, but the title of it is quite profound. So forest landslide frequency size influenced more by road building and logging than heavy rain, which is a very punchy statement. So this stuff that's kind of been the same forever. Well, of course, we're talking about changing needs in industry. Well, what actually has changed? And if we look at it from the company's start, well, in 1989, the big question when planning roads and managing roads was, how do I get there? So generally in the forest setting, there were some roads and logging activities, but networks were fairly immature, and really the main focus was get to that untouched resource and get in there and get things operational. Now, if we speed it ahead to today's lens, and not to paint everything with one brush, there's lots of locations where building new roads is still a core business consideration. But for many locations, the road network is fairly mature. There's not really much of a focus on getting to places that haven't been gotten to before. But there's still an opportunity to improve things. Now that could be looking for efficiencies. So it could be a matter of, well, we're able to use larger vehicles now, run B trains. Maybe we want to low bed further back onto our property than what we previously were able to. So upgrading the road to support larger vehicles could be one aspect of improving your road. It could be realigning to reduce haul costs, realigning to find more direct routes, etc. But aside from just making things better, there's the aspect of managing risk. So a lot of the time, many roads are going to be more of an asset than anything else. But roads are sometimes imperfect. And with those imperfections comes risk. So was it something that was built 20, 30, 40 years ago on a steep slope that is basically just organics bladed over onto organics and waiting for it to settle and slough out and fail? Is there ditches that are going to block or culverts that are blocked, and we could end up with washouts at undesirable times or contribute to something more dramatic like some of those landslides that we looked at previously? So from that side of things, our road network can be a liability, and oftentimes it's cheaper and better to tackle things head on and proactively rather than dealing with it after the issues manifested itself. So what else has changed other than just the road network maturing? Well, even if those roads were built with and planned and designed using the best information at the time, it turns out that our climate's changing. So a lot of those assumptions for peak storms, etc., were probably an underestimate. So climate change, we're expecting to deal with more frequent and more intense storms on one side, or it could be the exact opposite, where we're going to be dealing with more droughts. So both of those have interactions with our roads. From the more frequent, more intense storms, well, our road's going to be able to withstand those higher flows. Or if it's something like droughts, well, maybe our road is, again, acting as an asset, where the road itself can act as a fire break, or maybe it's just better access for fire suppression if need be. Well, if we're looking at improving things, well, what do we want to consider there? Well, we probably want to make sure that whatever we do, we have a lens of sustainability and considering what's going on. And that could be sustainability in terms of a buzzword, but really if we take a step back and look at that word from its meaning, the capable of continuing for perpetuity, that's not just a feel-good thing. There's value in it. We don't want to degrade the environment, and we want to keep our resources so we can keep using them and keep benefiting from them. So aside from just wanting to do it sustainable, there's operational needs. So one, we want roads that are safe. We don't want to have to worry about fatalities or people being injured or the public being injured, because a lot of our roads are mixed use roads where they're built for industry but used by community members, recreation, etc. So we want something that's safe for everyone. We want to be able to handle our expected traffic volume, so industry users and Joe Public. We want to be able to handle our design vehicle. So if we're planning to have a road that we can low bed on, well, it better be able to handle a low bed. And well, we want seasonality of use. So coming back to that climate tie that we had mentioned previously, well, if it's a location where previously or historically there was a lot of reliance on winter roads, maybe our winter conditions are less reliable in the future, and it makes sense to kind of hedge our bets and build more three-season roads rather than just relying on these long usable winter roads. And then there's duration of use. So sometimes we aren't really building roads to be there forever, and that's an important consideration, but you'll want to balance that as you're making decisions. So with that duration of use comes in the concept of resiliency. So do we want something that's going to be a permanent piece of infrastructure, in which case we want to withstand those peak storms over a longer return period? But if that's infeasible, well, maybe it makes sense to tackle it as a temporary road. But there's cases where a lot of temporary roads end up being permanent roads because they never get decommissioned. So making sure that you're actually planning for that decommissioning and then actually implementing that decommissioning is important too. So as we're finding those better solutions, we still want to weigh all those, the influence of those factors that are contributing to our road's performance. But realistically, we can't just focus on that. There's cost that is impossible to ignore. So we need to make sure that we're finding solutions that are efficient and cost effective in order to get the results that we need. So as we're making choices, if you are in the situation where you are building a greenfield project or planning a greenfield project, don't underestimate the importance of getting that road in the right location. So this is a quote that we really like. We've used it before, and we'll we'll use it again, but it's from Brian Chow, the former chief engineer at the BCMOF. And his statement was, the most important time in the life of the road is the moment you decide where it's going to go. And what he was getting at there is, well, where you put at that really does decide what are the challenges that you're going to be faced with maintaining and building that road. That's not to say that you're stuck with what was built as it was built. So if you are managing an existing road network, one option is keeping something as is, and it can be the right option. Another option is improving it, and that could be done proactively, or it could be done as a repair. So in the image here, we see that we're not moving the road at all, and it's being done retroactively, but the road's getting washed out, adding armor to make it more resilient. That's not always the best thing to do, though. It's not always best to keep it where it is and make it work. Sometimes that make it work mentality, you just end up perpetually throwing money at a problem. So then, maybe it was the road's in the wrong spot. Maybe it's a better decision to deactivate it, relocate the road, find an alternative route that avoids interacting with that problem. So where does that fit into technology? And yeah, it's kind of, from my own standpoint, I don't think of myself as being very old, but even the lens of how the industry's changed since I've entered the workforce, it's like living in the future. There's a lot that's changed over a relatively short amount of time, and that can be in our world related to design software, but outside of our world, there's other big meaningful improvements. So we've got things categorized here. There's been improvements with our ability to quickly understand the problem. So knowing what's there, and LiDAR's huge for that. So it gives us a high resolution topo surface. There's benefits outside of just topo, inventory, etc. So that's a big game changer. There's improvements that a lot of the time we take for granted, whether it's just field data collection. So GPSs are really good, even if we don't have some super fancy survey grade GPS. We are able to know where we're at in the field pretty easily now and collect photos, notes, etc., all georeferenced. And then another thing that I think goes kind of understated is improvements around GIS. So with that, your GIS system largely operates as a database of knowing what infrastructure is where. You can track condition. So having all that spatial information organized and readily available is hugely valuable. Now I'm going to skip over this middle one just to start. And if we skip the middle step and jump right to implementing solutions, well, there's tons of benefits there too, and really cool benefits. Not super flashy, but being able to have detailed construction plans saves a lot of downtime and missed opportunities. But if we look at kind of the more techie stuff, well, GPS, super valuable from an implementation standpoint. That goes hand in hand with machine controls, which again, super valuable for just improving efficiency. And then some things that we don't necessarily jump to think about is just improvements in materials. So it could be geosynthetics, it could be materials for culverts, and lots of other items there too. And then we've got that middle element, which I'm certainly, I think, more qualified to talk to and about than the other stuff. But between understanding the problem and implementing the solution, it's finding out what solution that we actually want to go with. So that's where design software comes in, making more informed decisions faster to get a better plan, better results, better schedule, reduced risk, etc. So we're going to lean into that one for the rest of our technology talk here. So road design is advancing. We're slogging away here and getting some really cool tangible benefits out of it. So terrain analysis, even without anything that is directly maybe what you think of for terrain analysis, just being able to visualize a high resolution topo surface at the click of a button and pan around and see what's there for the shape of the ground is hugely beneficial. And then we can, of course, tag on other perks like hydrology tools, polygonizing steep slopes, etc. Then from, well, how do we get the road in the right place? We've got Path Explorer, which is just wild in terms of how well it works, how much time it saves. And that is I want to go from point A to point B, put in your design specs and let the software give you well, several options that adhere to your design criteria and minimize costs. And then taking it a step further in terms of detail, we've got our earthworks optimization stuff. So that could be just looking at the haul. So figuring out where material should, cut material should be used as fill, and minimizing that haul distance is valuable. But we've, of course, back that onto the vertical optimization stuff where we'll adjust the vertical alignment to further reduce material movement and handling. And then again, well, terrain analysis, when we mentioned that before, that's kind of through the lens of what's there, but incorporating hydrology tools right in the actual road design interface is hugely beneficial to have a better idea of how you're interacting with that surrounding terrain. So we are going to run through a few quick software examples here, just kind of highlighting some of the functionality for those various tools. And to start, we'll look at a flat example. So this is a flat wet example. Just from a visualization standpoint, being able to exaggerate that vertical in the 3D to see where the little bit of relief you have is beneficial. And we can use the hydrology tools to, well, map where streams likely are. But for these flatter sites, identifying the ponding areas is just as valuable too. So those ponding areas are typically going to be your wet sites like bogs and wetlands, which we want to avoid. We can tie that into Path Explorer, adding those areas as higher cost areas, and then put in our design criteria to go from that point A to point B. And we can let it go. So we'll let it run, and it, yeah, for what it's considering and everything that it's considering, it's wildly quick. So here we've got our different solutions, and we'll just zoom in here momentarily. And we can see whether we're looking at the 3D or the plan, we're doing a pretty good job of avoiding most of the wetlands or the wetter areas. So we've got 5 options, and that would have been an input that we gave the software. Give me 5 options, but if we want to rank those various solutions against each other, we can, and we can see the expected cost being reported there. So that one's our cheapest, makes sense, most direct, but also avoiding a lot of the wetter terrain. So that was a flat, wet example. Kind of in line with our topic, or I guess one of the key mentions of kind of managing an existing network. Well, we'll look at a repair example. So here we've got the existing road, and probably be able to see it just out of the image there, but there's some pretty obvious washouts. So can't use that road as is, to say the least. So if we want to, we can go through and we can plan an actual repair. And before just mobbing equipment out there and throwing money at the problem, we can actually consider it, come up with a plan. We can end up with something like that. So design the road. We can even include additional details, if we want to go even deeper with construction level details, machine access, we can incorporate that. We can zoom in to wherever we'd like to zoom in to really look at things and evaluate things, understand the geometry of the site. And well, we can run those hydrology tools in version 12 right in location. And with that, we can calculate our drainage area to every culvert inlet and not just consider that topo surface before the road's there, but we can incorporate the ditch and see, okay, that much water is being intercepted. Okay, we can size our pipe accordingly. And we can have it all reported in real time as you're designing. So once we come up with a plan, we can obviously put together our documentation, have something that we want to go and implement. And that's, yeah, you can be as detailed or as thorough as you'd like with that. You can use it as a visual aid, or you can use it for something really detailed and really controlled with a really controlled solution during construction. Both have benefits. And then, well, from a, is this the best solution, or how do we want to schedule our crews? Well, we can look at earthworks, have our volumes, have a good idea of how long that's going to take to build. And well, one option is, of course, repairing what's there. And then the other one, and does it make sense? Now, that whole valley is a pretty nasty valley. Maybe we can reroute to avoid it. So we can use Path Explorer. We can put in all the areas that we'd like to avoid just for whatever reason. Here it's terrain and stability concerns. We can go from point A to point B, get our solution, turn that into a proper design. And we don't have to just try it from one location. We can try it from wherever we like. So pretty powerful in the sense of weighing options and coming up with the best solution that meets our needs, not just blindly picking a strategy and running with it because it was our first guess. Now, we'll look at another example here. So this one's not a repair job, but a steep terrain example. So here we've got the block boundary, the proposed block boundary, the topographies being displayed, so our 3D view. It's nice to know where water is. We run the hydrology tools. And well, we can plug that into Path Explorer, go from point A to point B, let it go. And this one took, I think in practice, like 10 minutes to run with. You can take that over into location, actually turn it into a proper design really quickly that minimizes our earthworks. And then we can look at it in more detail and really evaluate how we're interacting with the water. So on that right view, we've got our blue lines are the streams. Well, we can run the hydrology on the surface without our culverts being added yet. We could see what would happen if we didn't put our pipes in, where the water is going to be redirected, and then where we're going to starve flow from those streams otherwise. We could zoom into a particular area and kind of drive that home, see the impact. If we don't put culverts on those creek draws, well, we're going to dump a bunch of water off the end of our switchback, which we don't want to do. So that can create issues. So we put our pipes in and we make sure that we run the hydrology tools and we can see, okay, we're actually preserving the natural flow quite well. And there we are. So this example, we do like showing this example. Just it's a lot of the time these tools get used on new projects. This one was actually designed before the Path Explorer and vertical optimization were used on it. So the original design looked like this. Post optimization, running Path Explorer, we had a solution that looked like this. And yeah, this one came from the BC MOF. So shout out to Don for yeah, he asked to use the tool and try it on this project when the tool was in its infancy. So yeah, I think we're all pretty happy with the outcome. And then if we do that side-by-side comparison and actually, well, just look at it visually, the difference is pretty obvious. If we want to apply some metrics to it though, we've reduced the road length by 12%. We've reduced the disturbance area by 21%. and we've reduced the earthworks by a massive 67%. So yeah, quite a bit better. So, and of course, this webinar was quite a bit different from our usual format, but it is nice to do something that's a little more conceptual every now and again. So my goals in this, if you thought the technology stuff was cool, well, great. But that's really a secondary outcome. Yeah, really, aside from any technology stuff, we're quite sincere about this, that like this stuff does matter. The decisions you make now and how you handle situations now can have massive ramifications years or decades later. So considering it is yeah, super important. And how does this all kind of tie together? Well, first, we do need to acknowledge that roads have an impact. We ultimately want to just minimize that impact, make informed decisions, make sure that we aren't taking unnecessary risk and the impact that we have is reasonable. And if we look at those case studies, if we ask ourselves, well, could something different have been done that avoided this situation or reduced the impact of this situation? You can spend a lot of time diving into the details and trying to determine what went wrong, what were the contributors, what could have been done differently. That whole process is an investigation. If instead of doing it after the fact, if we do that proactively, look at all the available information and weigh the different outcomes, the costs, etc., to find something that is an optimal solution, and optimal from a very broad standpoint. So balancing costs, but also balancing safety. Yeah, environmental impact, etc. Doing that proactively is a design. That's the term for that. So yeah, it's kind of that old adage that an ounce of prevention is better than a pound of cure. So wrapping things up, all roads have an impact. Want to minimize it. The industry is changing. The world's changing. With that comes new challenges, but in line with that, there's changing technologies and improving technologies that make it even easier to find better solutions. So that's it for my spiel.
Awesome. Thank you so much, Matt. I hope everyone enjoyed today's very, very different webinar than usual. So we do have, and this is remarkable, we have extra time. So we can actually take a question or two if anybody wants to put one in the chat. So far, you guys have been a very quiet audience. Unlike our wind farm webinar from a few weeks ago when we had probably 6 times too many questions than we could answer. So we can hang out here for another couple minutes if anyone wants to pop one in, and we will be happy to answer them. Oh, I see one here. Is there going to be a link to the replay available? Yes. Yes, all of our webinars, they do get posted to Softree's YouTube channel, unless, of course, it's one of our support exclusive webinars, and those ones stay private. But yes, this one will be up on our YouTube channel. Yeah. Beyond that, any other questions, take a moment, type them in. Happy to answer them. It could also be a good chance for me to mention a few years ago, Softree, in collaboration with Jeremy Araki as well as Brian Chow, did put on a 4-part really in-depth webinar series where Jeremy in particular took us into a lot of design and detailed nuances about and reducing the environmental impact of roads. Now, of course, we've got some awesome new technology that'd be great to infuse into that now, but a lot of that core content is still super relevant, and we have links to those as well available on our YouTube channel. So if you have never seen that series, it is about 8 hours of webinar content, but really fantastic in terms of just looking at every single element from design to just even, yeah, how to build it. They've got tons and tons of information there and available. And with that, I'm going to say thank you for attending Quiet webinar audience today. Thank you, Matt, for the awesome presentation. I see lots of clapping, but little questions. So we're going to wrap up there 5 minutes early. Gift of time. Thanks, everybody, for being here, and happy Thursday. And happy Friday
Thanks,
to
everyone.
all you New Zealand, Australia folks who woke up early. Goodbye, guys.
Thanks, folks.